Welcome to the Phoenix Neutron Imaging Center. My name is Katie. I am going to give you a tour of what we do here. So at Phoenix, we are one of the only facilities in the world to provide commercial-grade neutron imaging services to the aerospace and defense industry and others for non-destructive tests. It's a test that allows manufacturers to look inside really critical components and parts to make sure that they're operating as designed. So if you'll come over here with me, I'll show you. This is our shipping and receiving area. So one of the things that we do at the Imaging Center is we image what are called energetic devices. So energetic devices are small components that have limited amounts of explosives in them. The way those parts are formed is it's like a thick metal housing with light amounts of explosives on the inside. And X-rays have a hard time penetrating that thick metal, and you can see some examples here. We don't have any of those energetic materials shown here, but just as a, just to show. Most of these parts are very thick metal and have some sort of plastic or something on the inside that you want to be able to see. So if I bring you over to the shipping and receiving area, one of the more important things that we do day to day is we receive these materials through the store and through this garage door here. So these materials are either shipped to us via courier or driven by the manufacturers themselves, and we are certified to handle all of that explosive material and move it through our facility accordingly. This is our fixturing area. The fixturing, so that's the way the blades or whatever we're imaging is positioned in front of the neutron beam. It's really important to position them in the correct way because these neutrons are moving very parallel, and if the blade or the energetic is tilted the wrong way, you're not going to see what you need to see quite so well. And our team works really closely with each and every customer to make sure that we design the fixture and the test in a way that everything that needs to be seen can be seen very clearly. This is where all the neutron imaging happens. So the neutrons are produced within the center of this big blue structure. So this is called a moderator. So it's moderating down the speed of those neutrons using a combination of heavy water, plastic, other such stuff. The team, both at Shine and Phoenix, has a just deep wealth of radiation expertise when it comes to the way neutrons behave due to the fusion research that we've been doing throughout phase 1 and continue to do through phase 2, 3, and 4. So what you'll see happening here is our team is putting the parts inside each and every collimator, and we do 10 images concurrently. So this is really important for redundancy and also allows us to basically image everything that needs to be neutron imaged throughout the course of the year. One of the unique things about our system as compared to our competitors is we're an accelerator-based neutron-producing system, which, as I mentioned earlier on, we have a beam hitting a solid target which produces a lot of neutrons, and that's how we make the neutrons for neutron imaging. Everybody else in the industry uses aging kind of research reactors to make those neutrons. So research reactors are nuclear reactors that were designed for their neutrons and not for the power that they produce, like the many power reactors we have throughout the United States. There are only a handful of research reactors left in the United States, and only, 3 in the US and 1 in Canada that will actually provide neutron imaging services. Fewer that will handle the energetic materials because, as it turns out, people don't really like having explosives close to a nuclear reactor. But again, this facility was purpose-built to do neutron imaging for those components, and the reliability of the system is so much better than anything that's ever been done in terms of neutron imaging. We can turn the system off, stop making neutrons, it becomes immediately safe from a radiation perspective. You can open the system up, repair what needs to be repaired, close it, be imaging same day. This is not typical with a nuclear reactor. I talked through what it means to do fixturing of turbine blades, but the other big portion of our business is energetic materials. Again, these are small devices used for various purposes, mostly in aerospace defense, for satellite launches, ejection seat mechanisms, things that just have to have an extremely high reliability. So as you'll see here, what Stefan and Sean are working on are fixturing energetic components. So these require anywhere between 20 minutes and 2 hours of fixturing time because they often are very small and they have to be positioned extremely specifically within the imaging box. So if you look here, these are all fixtures for various parts, and you can see the tiny little holes. Each energetic component is kind of dropped into that little hole so that it sits in a very specific position so that when the neutrons hit it, you can see exactly what you want to see. So as I mentioned earlier, the parts come into the receiving area that we bring them over here. So energetics fixturing has its own bunker, and that's because it is explosive materials. We designed this facility in order to house those parts. So those materials are fixtured in here. You'll notice all the mats. Everything is designed so that there's no static electricity charge that could accidentally set something off. The caution and the safety and the quality are extremely important in this part of the business. We have some subset of the energetic material in this room, but outside the building we have several magazines which are built in order to house even more energetic material so that we can do a high volume of neutron imaging. So we'll get big surges where if a reactor goes down, we'll get a lot of energetic materials and turbine blades all at the same time. So having a facility that can house and process all of that and sort of that surge model is incredibly important. And not only that, we have the capability to image almost all of the energetic materials that require neutron imaging across the United States year over year just out of this facility. Almost 100% of neutron imaging done commercially is done on film, so that requires us to have a dark room. There's a lot of processes and procedures in place. After they're developed, they come over to the image viewing area. I'd like to introduce Martin. He is our R&D lead and is going to talk us through what it means to look at a neutron image.
Thanks, Katie. So if you've ever had a chest or dental x-ray, this might look pretty familiar. Neutron images are black and white. But unlike an X-ray, there's certain things you can see in a neutron image that you otherwise wouldn't be able to see. Neutrons, on the other hand, as you can see with this tin of Altoids, you can easily see through the metal tin, but you can see each of the individual sort of candy pellets that's in here. And these are actually sort of a similar shape to what you'd have in a real explosive device. So this shows you that you can really have very high contrast to energetic or explosive material through metal containers.
Fantastic. All right, well that concludes the tour of the Phoenix Neutron Imaging Center. We've talked through the importance of material handling. You saw all of the hundreds and hundreds of parts that come in through our door each day that have to be handled with care, fixtured with care to make sure that we get the highest neutron image possible. You saw that we went into the bunker where we produce the radiation and all of the neutrons that we need in order to produce a high quality neutron image. The sheer reliability of the system and how different it is than everything else that's out there doing neutron imaging, how we can have 99% uptime. We can run 6-7 days a week if need be to support this industry and all the parts that require neutron imaging across the United States. The just sheer capacity of neutron imaging that we can do both for the explosive materials that you saw because we have the capacity to house those and ship them here and keep them and do the neutron imaging, and the high volume of turbine blades that come through the door. All of this speaks to the things that are the most important to us, as you can see in the banner behind me: the safety, quality, and on time. That's it. Thank you for taking the time to tour with us.